rate constant for a second order reaction is 0.47 reciprocal moles per liter per second. If the initial concentration of reactant is 0.250 moles per liter, that's molarity, how many seconds until it decreases to 0.20 moles per liter? So it might be nice that we're told it's second order. Sometimes you're not told and you're just given the rate constant. How do you feel about that?
It helps because we can actually put it in the equation.
Well, yeah, you have to know which equation to use. So maybe to stall things out, I'll ask you, is that going to work for you?
Isn't the second order positive K? Or?
Very good question. And you are right. Whoops. So there's our two equations. We want to know which one to use. This one is for first order. This one here is for second order. So we're told second order here, and you want to be able to recognize second order units of the rate constant. So it says how long until it reaches a certain concentration. So we all like algebra, right? Well, that's why it was a prerequisite for this course. So what I'm going to do first is I'm going to subtract this term from both sides. So far, so good? All right, now I want to divide both sides by my rate constant. And I imagine if I was taking a quiz, at this point, I'd plug in the numbers. All right, so now I'm going to just look through here. 1 over the concentration sometime down the road minus 1 over the initial concentration divided by the rate constant.
Isn't the initial concentration 0.25?
Thank you for just not letting me go on. There's the initial concentration. Here's my rate constant. Then thank you so much. So on my calculator, I'm going to go 1 divided by this minus 1 divided by that, and then I'm going to hit enter to keep this all together. I'm going to divide by that number there. So here goes. 1 divide 0.2 minus 1 divide 0.25. Then I hit enter. That's interesting.
They come out to 1.
Yep. Divide 0.47. And this m is really going to cancel with the m's in there. And that's going to leave me with seconds. 2.5 seconds. Any questions on that? Well, since we got everything written up here, let's check our work. What if the question said a certain second order reaction had an initial concentration of 0.25 moles per liter, 2.12 seconds later, the concentration decreases to 0.2 molar. What is the rate constant?
Don't you still use the same equation, just plug things in where they could be and just...
Right, it would look like this, right? And the exciting thing, of course, is my units are going to come out in second order units. And if I round, any questions on that one? A first order reaction has a rate constant of 0.33 reciprocal minutes. It takes blank amount of minutes for the reactant concentration to decrease from 0.133 molar to 0.066 molar. So once again, we see the units of first order rate constant. That tells us which equation to use. Of course, you were nicely told. So I'm going to just write that equation out and do something very similar to what we just did. Rearrange this equation in terms of time and then just plug everything in. So I didn't explain each algebra step, but I subtracted this from each side, brought it over here, and then I divided each side by a negative k. Brought that down like that. All right, so the natural log of 0.066 minus the natural log of 0.133 divided by this rate constant. Should have let me go and blow things up. And I might have noticed, because we're going to get a negative number up here. And then the negative, it'll fix itself. So here we go. Natural log 0.066 minus natural log 0.133. Enter. So I hit enter so it doesn't divide 0.33 into the log of this and then subtract. So I'm going to worry about my orders of operation. And up in the numerator, I get negative 0.70069 something divided by a negative 0.33. We only know the constant to two significant digits. Any question?